Hello, and welcome to Logic Gate Introduction Part 2. The last introduction ended a little bit harshly because my video was cut off. I reached 10 minutes and stuff, so yep, sorry about that. That's just why it ended that way. I'm gonna put a notice there so that you won't get confused. So basically, the last thing I was doing is I was explaining the third pin on this SR flip. So what it does is if I turn this off and on, I can turn these off and on all I want, but they're not going to write into the queue and not queue. If you've watched my processor videos, then the registers had a write enable. This is actually the latch I used for my registers, these things. If I want, I can show you. Actually, sure, I'll show you the register schematic. Sure, why not? So basically, the write enable. I was explaining that if I turn this on, off, and on, and it won't do anything unless I have write enable on, and I clock it by turning it on and off. So now that this is on and it feeds into there, feeds into set, and then set is going to set Q on, and then Q is going to be on, even if write enable is false. And stuff. Or set and reset are 0. Even if any of this is 0, it's going to keep on being on, like I mentioned in the last video with the SR flip-flop and stuff. I don't really use much of any of the other flip-flops and stuff. Why do I keep on saying that? I mean, there's a few other ones that are popular. I mean, I can go on Wikipedia and tell you the basics of that. Although, I mean, if you want, this is a D flip-flop, a JK flip-flop, a T flip-flop. You can go onto Wikipedia yourself and explore those flip-flops. I mean, I personally don't care for them unless I have a direct use for them. So, yeah. So, now we can go to understand my registers. Let's close this. Let's keep on closing it. Come on. I don't want to say it now. Okay. Now, here's my register. And if you view this, then, like I was saying, it's just a bunch of SR flip-flops. 4 of them, because it's 4 bits connected to data. So this is data 1, which it has like the set and the reset. So basically the reset is inverted, so it can all be in one data, because if I don't invert it, then if I turn it on and off, then this will keep on being 0. I want it, if it's on, then this is on. If it's off, then this is on. If write enable, like clocks. So then there's 4 of those. And then this side is basically just the read enable. This is the read enable switch. So if I turn this, so these light bulbs will only display if I turn this read enable switch on. So it feeds into those and stuff. So yeah, this is all my register is. I can show you a few more things. A full ladder is one of the things that's also in my circuit. So basically the way this works is that it adds 3 bits, and yeah, so it basically just adds 3 bits and then outputs them. So this this is the output switch, and this is the carry switch. So this is going to output to the next full ladder, or just to output, and this is going to be the carry. So this is basically another place. This is like a place above this place. So you can think of this as the ones place and the tens place, or the ones place and the twos place, because 1 plus 2 is 3 in binary. So if we turn, oh, I can turn switches. So if we turn any of these on, then that one's going to output. And the way this works is that, so basically these two feed into an XOR gate, yeah, an exclusive OR gate, which basically means, so if one of them's on, then this turns on, but if both of them are on, or none of them are on, this is going to turn off. And then that feeds into that, and same principle here, and so that light bulb turns on. But what if I turn C on? So this is off now, which means that is off, but that's still on, and this is feeding into another XOR gate, which is going to turn that on, since this is not. So what happens if I turn this on at the same time? This XOR gate shuts off, but then this and this AND gate comes on because one of these is on, so that XOR gate's on, so it's feeding into this AND gate, and then C is also feeding into this AND gate, or yeah, ABC. And then this AND gate is feeding into this OR gate, and then this is carry. So it's going to carry the value. This is like the tens place, or the twos place, since 1 plus 1 is 2. And I can do this for any combination of these, same principle there. But if I turn both of those on, then this OR gate's going to shut off, but this AND gate's going to come on, because these outputs are connected to an OR gate and an AND gate. And this AND gate's going to turn on, and then it's going to cycle through there. So what happens if I turn all three on? Oh, the power. This XOR gate, I mean, why am I calling it an OR gate? This XOR gate shuts off, but this AND gate comes on, and it feeds through the OR gate. And so this light bulb turns on, because like I was saying before, this feeds into this XOR gate. Since this XOR gate's off, this XOR gate's on. And then this light bulb's on. So, yeah. And then, basically, my adder is just a chain of these. So this is a half adder, so if one of them's on here, I just want to check my time. I have a bit of time. So if I go for this really quickly, then, so if one of these are on, then this OR gate's going to come on into this AND gate, but it's only going to be on this light bulb. This AND gate is connected to this light bulb, but it's only going to be on if this AND gate doesn't cut off, because it's connected to the NOT gate, and then that's the second input of the NAND gate. But if it... Oh, I'm coming! Oh, dear God. Okay, sorry. So I have to end this prematurely. I'll probably make a third Introduction to Logic Gates video, or more like components and stuff. Bye. Peace out, guys.